Hi guys, welcome to chapter 10. We're going to be talking about control variables and internal validity. I know it looks like a lot, but don't worry. I'm going to be going like section by section and then I'll explain to you what's happening there. Okay, so first things first, we have control variables. Now, I've basically set this up the same way on both sides. So you'll have the key point, definition, some quick points on the side, and then some like extra things to consider, and then I'll tell you how both of these combine into being related to each other basically. Okay, so control variables. Basically, the quick definition here is they're variables that are held constant on purpose across sessions. So basically they should not vary, right? If it's in control, should not vary. So I've underlined it in red, so it's kind of something to keep in mind. And control variables cannot be used as an explanation for changes in the experiment. So a third variable, you guys have also heard of that. Third variable is different than a control variable because a third variable you can use as an explanation, but for control variables you cannot. So there's the difference between those two. Here we have some quick points for control variables. Sorry, I feel like I'm speaking super fast. My bad, let me slow it down. So some quick points for control variables are that they're important for internal validity. We'll get into that in a second. And they're not the same as manipulated variables. So again, here, if it's a control variables, they're held constant on purpose. Whoops, that's my finger, my bad. So the variables that are held constant on purpose versus a manipulated variable where obviously the word manipulation is in it. So we're changing something there. So these ones should not change. Basically, to sum up, and here are some examples. Dr. R gave you guys these in these slides as well, but I actually added in one or two of my own. So time of day is something that he's mentioned. So I'm just going to use my study, the one I did last semester, as an example. So I did the effects of gender and stress level on math performance. So we conducted our study, just like in public areas around CSUN, like in front of the OVIA and places like that. So time of day is something I also mentioned actually in my results section, I believe, because if we had recruited, let's say during different times of day, like not just in the afternoon, but like at the evening or maybe like super early in the morning, like there's different kinds of students depending on the time of day it is. So we might have gotten like different responses. It really might depend. Temperature is also important. Let's say you're in a specific room and if it's super hot, kids can't focus because like they can't be focusing on math, they're kind of too worried about sweating or whatever it is. And same thing if it's too cold, similar issues. Location is important. Let's say you're like, for example, you're taking an exam, right? Like if you're taking the exam in the same exact classroom that you've always been in, it's less of a control variable. However, it becomes a control variable, for example, in the case of this pandemic. Our location of the class has changed, so that is definitely a control variable to maybe that's why you might not be doing well in class, but hopefully that's not happening. Lighting in room is also another one that Dr. R mentioned. It's pretty self-explanatory. I won't get too much into that. Temperament and speech is something that I wanted to bring up too, just as my own example, because let's say, for example, like when I was conducting my experiment, right, last semester. So let's say I was super nice, like my temperament was like, it was like happy and whatever. And my speech, was pretty easygoing. So that would provide as a low stress environment. That's actually what we did. So if we change our temperament to like, oh my God, guys, like, let's go, hurry up, like giving them time updates and things like that. And my speech was very maybe like cold. It wasn't as like warm and welcoming. That could definitely be a control variable. Hopefully that wasn't too long-winded, but that's basically control variables. Hope that was not too difficult to understand. And now internal validity. So internal validity are one of the 3 rules of causation. So definitely the other 2 are temporal precedence and covariance. So definitely read up on those if you are totally confused as to what those are. But basically the quick definition is right here. So it means having the ability to control anything in your study that might provide an alternate explanation. So internal validity is definitely something we want to keep in track throughout the entire experiment. And here, a little arrow, it's important because the researcher cannot claim third variable issues. So Third variable issues means that, there's something on the outside that is causing some issues or some disruption in the data. But if there's good internal, you cannot claim these third variable issues. And some quick points. It's different than internal reliability. Remember, reliability and validity are two different things. Again, think of like a dartboard. So if you're hitting the darts in the exact center, that means you're being valid. But if you're hitting them like off to the side, but it's all off to the side, then that's, reliable. So good internal validity. This is actually something super important. I would definitely like write this down somewhere, like, for your exam or just, to have. Good internal validity means that the IV is directly causing the DV. So there's no alternative explanation. And we can see that one yields or leads to the other. Okay, now some important things to consider with internal validity. Sorry, it's down here. Okay, so there's 6 things. These are all mentioned again in the slides, but I'm just gonna go over them real quick. So if there's a biased researcher, if I'm a biased researcher, let's go with something like, I don't know, super like, potentially it's definitely happened in the past. So biased researcher in the sense of maybe they're a bit racist or they're sexist or something. Maybe so here we would have let's use the temperament and speech example. So maybe they're not as nice towards a certain gender or a certain background, that would definitely be a biased researcher. If the researcher is aware of the hypothesis, if you're kind of already aware of like what you feel like you want your results to be, you might be forcing participants to answer in a certain way. So there's definitely some bias with that second one. Self-selection is the third thing to consider here with internal validity, which means participant choice. So if the participant is choosing, technically, the researcher no longer has the reins. They're no longer in control of the experiment. Somebody else is. Third variable is pretty self-explanatory. We've gone over that a bunch of times. Poor measurement. So if you're not using the correct measurement, let's say for instance, this is another thing that happens a lot in the world with children and individuals on the autism spectrum disorder, who have ASD, So let's say they were not given the proper diagnostic test. That would definitely be an example of poor measurement. And then again, environmental confounds. If the lighting is different, the time of day is different, all these things, that might definitely be an issue here. So final point. So control variables and internal validity are related because if there's a good or strict use of the control variables, there is no threat or there's little threat to internal validity. So that's basically how these two things are correlated. If our control variables are solid, then our internal validity is going to be solid. Pretty basic stuff. So, wow, that was 8 minutes. Okay, hopefully that was not too painful. Here's another quick glance at each side. Hopefully everything was legible and this wasn't too painful. But yeah, hope you guys understood those.